Hello, good morning students. Today we are to discuss about the next applications, that is second applications. And second application is if two vectors are acts as right angle. It means here two vectors are mutually perpendicular to each other. So this is the meaning of these applications. So there are two vectors which acts as a right angle. Right angle means what? So the angle inclination between two vectors is exactly equal to 90 degree, like this. Okay. So suppose this one is x-axis and this one is y-axis. Okay. So when these two vectors are right angle to each other, or we can say if they are perpendicular to each other, then how we can calculate the resultant and the direction of these two vectors. Okay. So let us discuss about this second application. First application we have seen already in our previous videos, that is when two vectors they are in the same direction, so they acting in the same direction. At that time, how we can find out its resultant and its direction, we have seen already. So let us discuss about the second application. Now see, in this second application, vector P and vector Q both are right angle to each other. It means that the angle inclination between them is 90. So when theta is 90, then we have to write the values from trigonometry, that is from cos 90 and sin 90. So the value of cos 90, so the value of cos 90 is equal to 0 and the value of sin 90 is equal to 1. So you should remember these values. Cos 90 is always 0 and sin 90 is always equal to 1. So this is about the trigonometry. So these are the trigonometry. Now first of all, we have to find out the value of resultant, that is the value of capital R. So how we can find out the resultant value? So for that purpose, resultant value, that is R, is equal to under root P square plus Q square plus 2PQ cos theta. P square plus Q square plus 2PQ cos theta. Okay. So here theta is 90. So we can substitute the R is equal to under root P square plus Q square plus 2PQ cos, instead of theta we are putting 90 degree, because cos theta is here 90 degree. Why 90 degree is here? Because these two vectors are perpendicular to each other. So that's why instead of cos theta we are putting cos 90, and we know the value of cos 90. The value of cos 90 is value of cos 90 is 0. So that's why we are putting there 0. So R is equal to resultant vector R is equal to vector P plus vector Q plus 2PQ cos 90. Cos 90 means what? The value of cos 90 is equal to 0. So that's why we are putting here 0. So 0 into 2PQ, it becomes 0. So R is equal to resultant vector R is equal to P square plus Q square plus 2PQ into 0, that is 0. So therefore we can write vector R is equal to P square plus Q square. So this is equation number 1. So this equation 1 represents how we can calculate the resultant vector of these two vectors which are perpendicular to each other, or we can say which acts as a right angle. Okay. When two vectors are right angle to each other, then what is the resultant? The resultant is absolutely under root P square plus Q square. So you should remember this concept that is r is equal to under p square plus q square. Okay. Now after finding the value of resultant, just we have to move towards the direction. How we can find out the direction of these two given vectors which are perpendicular to each other, or we can say they which are right angle to each other. So what is the formula to calculate directions? We are familiar with the formula. So for direction, we are using their notation alpha. How we can find out the direction? There is one particular formula. Which are there? Yes, anybody? What is the formula to find the direction? So tan alpha is equal to q sin theta upon p plus q cos theta. So this one is the formula. So with the help of this formula, we can easily find out the direction. Okay. Now what we have to do here? Just we have to substitute the value of theta, because theta we are considering 90, and we know very well cos 90 is equal to 0 and sin 90 is equal to 1. So that's why we are putting just the value of sin theta and cos theta. So this equation becomes tan alpha is equal to q as it is into sin, instead of theta write down here 90, p plus q cos 90. Now we will put the value of sin 90 and cos 90 here. The value of sin 90 is 0 and the value of cos 90 is equal to 0. So therefore tan alpha is equal to q into sin 90, that is 1, upon p plus q into cos 90, that is 0. What will we get here? Tan alpha is equal to q into 1, that is q, upon p plus q into 0, 0. So therefore tan alpha is equal to q upon p. So therefore direction alpha is equal to tan inverse of q by p. So this is our equation 6. So you have to remember these two equations, which are very important in this case, in this particular application. So first formula here we get, that is resultant r is equal to under p square plus q square, and second formula here we get for direction, that is alpha is equal to tan inverse of q by p. So this resultant and direction, when we have to use only at this condition. So see, the condition is when the two vectors acting right angle to each other. It means that if two vectors they are perpendicular to each other, at that time you have to use these concepts. That is how we can calculate the resultant of this, that is r is equal to under p square plus q square. So you always use this formula in this condition. Condition is two vectors must be perpendicular to each other, or we can say two vectors are acting here right angle to each other. So after that, if you want to calculate the direction in this case, so alpha is equal to which formula you can apply? Tan inverse of q by p. Okay. So this is about the second applications, that is if two vectors acts as right angles. Okay. So tomorrow we will discuss about the next applications. So till then, thank you.